Good evening, class. You are welcome to today's class. Today, we shall be looking at stoichiometry of reaction, the calculation of moles of reactants and products in a chemical reaction. The calculation of moles, it might be in terms of gram of reactants and products that are involved in a chemical reaction. The first question which I be treating today is this question. The question says, calculate the mass of solid products obtained when 16.8 gram of sodium hydrogen carbonate was heated strongly until there was no further change. The equation for the reaction is this. Now, let's go. The reaction is between the heating of sodium hydrogen carbonate to give sodium carbonate, water, and CO2. So what are we going to do? Let's calculate the number of mole. The number of mole. Let's calculate the gram molecular mass of this and this, because this is the only solid in the product. This is in gaseous form and this is in gaseous form. So the number of solid product obtained. The question is asking us to calculate the mass of solid, the mass of sodium carbonate that will be obtained. Now, gram molecular mass of sodium, gram solution, gram molecular mass of NaCO3 is, we have sodium plus hydrogen plus C plus 3 oxygen. So that's 23 plus 1 plus 12 plus 3 into 16. So, and if we solve it correctly, we are going to get 84. You're going to get 84. So then gram molecular mass of sodium carbonates. Let's calculate this one too. We have 2 of sodium plus carbon plus 3 of oxygen, and we have 2 into 23 plus 12 plus 3 into 16. So it will give us 2 times 3 is 6, 2 times 2 4 plus 12 plus 3 times 6, that's 18, and it's 4. So we are going to get 106 gram per mole, But according to this reaction, according to the equation, 2 mole of sodium hydrogen carbonate give 1 mole of this. So 2 mole of sodium hydrogen carbonate gives 1 mole of sodium carbonate. So 2 mole, this is 1 mole, so 2 times, because a mole of sodium hydrogen carbonate give us 84. But according to the equation, we have 2 of it there. So 2 times 84, 2 times 84 gram gives 106. 106 gram gives 106 gram of sodium carbonate. So the question is now asking us what 16.8 of sodium hydrogen carbonate will give. Therefore, 16.8 gram 16.8 gram of sodium hydrogen carbonate will give S gram of sodium carbonate. So we now have S gram is equals to 16.8 multiplied by 106 gram divided by 2 times 84. 2 times 84. So let's do that. Let's quickly do that. 16.8 multiplied by 106. This one gives us 1780.8 divided by 2 times 84. That one gives us 168. Let's calculate. 1780.8 divided by 168. So it gives us 10.6 gram. So that means 16.8 gram of sodium hydrogen carbonate will give 10.6 gram of sodium carbonate. That is it. So if a question is given, you look at the relationship between them in the equation. From the equation, you can calculate it. Let's solve another question. This is another question. This question says, question number 2. This question says, calculate the number of mole of calcium chloride that can be obtained from 25 gram of limestone in the presence of Essex acid. The equation for the reaction is this. So the question is asking us to calculate for the number of mole of calcium chloride, but there is no information given about calcium chloride, whereas there is information about limestone. That means there is a relationship between them. So we look at the relationship between them. So let's calculate for calcium carbonate. So far, since we have been given information about calcium carbonate, so let's calculate the number of mole of calcium carbonate. Solution: number of mole is equals to reacting mass over molar mass. So number of mole, reacting mass of calcium carbonate, we were given 25 gram. So we have 25 gram divided molar mass of calcium carbonate. Let's calculate it. That is calcium plus carbon plus 3 of oxygen, giving us 25 divided by This is 40 plus 12 plus 3 of 16. If we calculate correctly, we are going to get 25 divided by 100. 25 divided by 100. That will give us 0.25 mole. That means it is 0.25 mole of calcium carbonate. The number of mole of carbonate. But the question is asking us to calculate for calcium chloride. So according to this equation, 1 mole, since 1 mole of calcium carbonate produces 1 mole of calcium chloride. So the relations between them is 1:1. So whatever happens, since they are having the same mole, then 1 mole of this give this, then 0.25. Therefore 0.25 mole of calcium chloride will be produced. So let me tell you one clue. Whenever a question is given in chemistry and there is no information given about that particular compound, look at the equation between them. It is either you relate them according to the number of mole or according to their masses. So this aspect is stoichiometry reaction. See, it is the aspect that we calculate the amount in gram or in mole of reactants and products that are involved in chemical reaction. NB, let me give us some clues. NB, 1 mole of any substance will contain 6.02 times 10 raised to the power 23 atoms or particles or molecules. Again, 1 mole of any substance, of any gas at STP will occupy 22.4 dm cube. So if we know this, it is simple to calculate any question given regarding mass volume. Without wasting our time, like when they ask us to calculate the number of look at this question. So let's look at the question to round it up. Calculate the volume which 3.2 gram of oxygen will occupy. So this is between mass and volume. What have we said? I've given you before that a mole, 1 mole of any gas at STP will occupy 22.4 dm cube. So a mole and a mass, there is a relation between them. 1 mole. So 1 mole of oxygen. This is oxygen, it's O2. A single oxygen is 16. So to calculate its molecular mass is 16. That means it is going to be 16 multiplied by 2, which is 32. That 32 gram. So that means 1 mole of oxygen is equals to 32 gram. So since we want to use mass in place of mole now, we use 32 gram. If we need mole, we will not use 32 gram, we use 1 mole. Each compound has its own gram that will be equivalent to its mole. So in this case now, it's between mass and volume. But this is the standard. A mole of any gas will occupy 22.4. But in this case, we need mass instead of mole. So each compound has the mass that its mole we will. So that means 32 gram of oxygen occupies 22.4 dm cube at STP. The question says, what will this gram occupy? 3.2 gram of oxygen will occupy x dm cube. Just cross multiply. So we have 3.2 multiplied by 22.4 divided by 32. So let's solve it correctly. We have 3.2 multiplied by 22.4. That gives us 71.68. 71.68 divided by 32, and that will give us 2.24 dm cube. So we just need to calm down. Please don't forget, this is where we are going to stop for today's class. Don't forget to subscribe to our channel for our subsequent series. Subscribe, like, and turn on your notification. Thank you.